Good morning and welcome back. This time I'm going to look at parallel circuits. So I'll write that down. And for those who are interested, it's on page 464 of the textbook. Right, so again, we're back to the definition here. And again, this is what you could have to learn. The components, there could be resistors, there could be bulbs, there could be anything you want. The components have the same voltage and the current splits. Now, if you notice, that's the opposite to series. Fair enough. It's the opposite to series. What do we need to do to understand this? Well, again, we're back to dear old friend Ohm's law. And I know this is not technically Ohm's law, V equals IR. Ohm's law states that the voltage is proportional to the current at a constant temperature, but V equals IR we need to use. So, I just to put you in here, I'm not a fan of this product rule that you'll see in the book because, well, make a rule that works simple. So we're going to look at the first circuit. We'll just look at this circuit here as I draw it. I have to watch about 6 different things at once here. So there it is. There's two resistors in parallel. Do not use one above the other. That is not true. So the current comes out, follow the blue spot, the current. So I'm going to say 2 amps comes out of this. Why? Because I'm making up the question. Right, so 2 amps comes out of this. So out comes the 2 amps. Now notice that these two resistors are the same. They are not always the same. But in this case they are the same. So the current comes down here and it comes to this junction. And it's known as the conservation of charge for those of you who want to do A level. But because the two resistors are the same, the current splits equally. But remember what I'm saying, the current only splits equally here if these two resistors are the same. So 2 amps comes down, 1 goes that way, 1 amp goes that way, and 1 amp goes this way. Back round, 1 amp there, 1 amp there, and then for the about 2 amps going back into the cathode of the cell. See that? And then back round it goes again. Right, so what's the voltage across that? Well, that's the same as I times R. Up here, look, there it is. So there's 6 volts across that. And there must be 6 volts across that. Because they're in parallel and have the same voltage. So that's the same as this circuit. I have a 6 volt supply and I have 2 amps coming out of it. And there's my resistor. There's my resistor, like so. Well, in my world it's like that, but virtual world hasn't got there yet. That's 3 ohms because 2 times 3 gives me 6. Now, this is only if the resistors are the same. Like up here, these two resistors are the same, so therefore you simply have them, but you only have them if they're the same. So write that down. If the resistors are the same, simply have. Fair enough? Like for example, if I take these two resistors here, here's 2 resistors, they're in parallel. How do I know they're in parallel? Because the current's going to split where the blue dot is, right? And I'm going to give these, and they're the same, so they're both 30 ohms. So that would be the equivalent of one resistor of 15 ohms. Now, we could draw this rule out and I could show you, but I don't think it's worth the time. But I'm going to turn the page on its side, and the reason I'm turning on its side is so that you can see this. So 1 over R total is equal to 1 over R1 plus 1 over R2. Bit of advice for these. That's so important. Bit of advice. See, when you're doing this 1 over R total and 1 over R2 and 1 over R1, you use the calculator. Just in case your fractions aren't good. So you use the calculator. Fair enough? You were told to use the calculator. So now I want to look at these equal resistors over here. Oh, that's, I want to do ones that are not the same. I want to do ones that are not the same. So here we have a 12 volt supply, right? And here are two resistors in parallel, and the two resistors have different sizes. This is going to be a 6 ohm resistor, and this is going to be a 12 ohm resistor. So I made the question up, so I should know. There's a current of 3 amps comes down here. So follow me down. There's the blue spot. Follow down. Down it comes to this junction. And the current's going to split because, look up here, voltage is the same, but the current splits. Now, if you were current and you were coming down here, which path would you take? You take probably the least, but there's always a smart fella tries to juke around the other way. So I want to see, what could I do? I want to find out what way this current splits. So let's go for our rule. 1 over R total is 1 over R1 plus 1 over R2. So now I'm going to sub, there's R1 and there's R2. So 1 over R total is 1 over 6 plus 1 over 12. 1 over R total, common denominator is 12. 2 twelfths is the same as a sixth, and 1 12th is the same as 1 12th. So 1 over R total is equal to 3 over 12. Now, listen to me make a fool of myself. Warning, warning, warning. You remember to throw that upside down, because that's where the mistake is. That's 1 over RT. You want RT, so it's 12 over 3. Throw this side upside down, throw this side upside down. So that's the equivalent of 4 ohms. So I could replace that whole circuit up there, 12 volt supply, 3 amps coming out of it, 4 ohms. Yes. Now I'm going to try to get this blue spot to follow me up the page. There we are. There's my 12 volt supply. I know there's 12 volts across this because they have the same voltage. 2 times 6 gives me 12. So the current there is 2 amps. 1 times 12 gives me 12. So that's 1 amp. 1 amp and 2 amps gives me 3 amps. The current splits. So there's that question done. Now we're going to look at another question here. Let's see what I have prepared here in my tiny skull. Right, I'm going to have a 24 volt supply. I'm going to say there's 12 amps coming out of it. Remember, I have made this question up, that's why I know. Right, there's my, hold on, just to undo. Undo, that's better. Comes into a 3 ohm resistor, back up round, and then up in here I have a 6 ohm resistor. And I want to know what current goes through these two. So, what could I replace that whole system with? So 1 over R total, they're in parallel. How do I know they're in parallel? Because the current splits, so therefore they have the same voltage. Both have 24 volts across them. So 1 over R total is 1 over R1 plus 1 over R2. So 1 over R total is 1 over 3 plus 1 over 6. So the common denominator, well, get your calculator out, right? Do you believe I have a calculator? Yeah. There's the calculator. So that a third plus a sixth gives you a half. Warning, warning. Why is the fool making a fool out of himself? So do you remember? Throw it upside down. So that's the same as 24 volts going through a 2 ohm resistor. So the current's going to be 12 amps. Fair enough? See what I'm setting my question out? You're supposed to get, this is where all the marks are. If I just wrote down 12 amps there, I'd probably lose 1-2 marks. Well, 2 out of 3. So although I got the right answer, I knew I was doing a failed. So I'm going to go back up here. I know there's 24 volts across this. 24 volts across that. So I equals V over R. 24 divided by 6. 4 amps. I know there's 24 volts across that. I equals V over R. 24 divided by 24 divided by 3 is 8 amps. 8 amps and 4 amps gives you 12 amps. Fair enough? So he comes down here. 4 goes there. 8 amps goes there. That's it. There's your series and parallel done. So parallel, the components have the same voltage and the current splits. The formula you need to know, do not know the product over sum, not what the paper is written on. Know 1 over R total is equal to 1 over R1 plus 1 over R2. Warning, warning. There you are, making a fool of myself again. You have to find R total, so you throw it upside down. Now there's your parallel circuits done. See you later. Toodle pip.